Hello everyone. We are here to talk about speech assistant. So what is speech assistant? Speech assistant is a feature to capture the voice and convert it to text. Why we need speech assistant? So main idea behind this feature is to enable doctor to capture the required data quickly so that they can spend more time with the patient. We can read more about speech assistant on the Bahmni wiki page. This is the Bahmni wiki homepage and you can search for speech assistant here. So this is a speech assistant page and you can read more. So we'll look into the feature, how we have implemented it. This is a high level diagram. So we have used Vakyans, which is an open source product, which is helping here to speech to text conversion. We have used two images, which is speech recognition open API. It is responsible for speech to text conversion and it needs language model for it. Second one is the proxy, speech recognition open API proxy. It is making a gRPC call with the audio stream to the API and getting the text back. So you can read more about Vakyans here. So go to developer guide. We are using the speech recognition streaming API to get the text back in the real time. This is the Vakyans architecture and this is the proxy service and why we need proxy service. You can come here and read more. Okay, let's go back to the speech assistant. So as I mentioned, this open API need a model. So to download model and dockerize these Vakyans with Bahmni, we have a repo, speech assistant package. Okay, so here we have a script in which we can pass a language and we can download the language model for that language. Okay, so let's see the dockerization part, Docker compose file. So we have downloaded the model and this is how we are doing the volume mount of that models. Okay, this is the open API image and this is the proxy. Proxy need a language map for which this open API will be converting speech to text. So this is how we have doing the volume mount for that file. Okay, you can have a look. Going back to speech assistant. We have developed a macro front-end application and you can refer that here. Okay, so all the API UI code are available in this macro front-end and it can be bundled. Right now, bundle file is available on the GitHub pages from where we can refer the bundle file and we can hook it to the Bahmni web. Okay, so front-end will create a socket connection with the proxy for bidirectional communication and proxy will make a call to open API and get the text back and it will serve to the front end. This is how this speech assistant is working. So we'll have a demo first, then we'll talk more about Vakyans.
In this video, we'll be seeing all functionalities and use cases which we covered for speech assistant application. I have logged in into Bahmni and I'm going inside clinical module. We have enabled speech assistant for active patients. So when I click on active patient, we can see a floating button in the bottom right corner. So when I click on the notes, we can have a start recording button which captures the voice and you'll see the text in the text area. So now text area is empty because there is no active consultation notes for this patient. So while recording with the mic, save notes button will be disabled and you can't edit the text. I'll start recording. Patient presented with a severe headache. Patient does not have any previous diagnosis of hypertension. Patient has a family history of hypertension. Advised to take paracetamol once a day. I'll stop. So yeah, it captured whatever I have spoke in, and it displayed in the text area. When you click on the save notes, you'll see a notification coming here. Um, Now it does not have an active consultation encounter. As soon as you click on the save notes, it will create a active consultation encounter for this patient. Now I'm clicking on this save notes. See, as I mentioned, there is a notification saying save notes successfully. So when you go into the visit dashboard, you'll see the saved consultation notes here. So this is the consultation notes which we saved. When I open this, it will fetch the consultation notes from the active encounter and it will display in the text area. And we can actually edit the consultation notes. Apart from audio support, it also has a keyboard support. We can edit the consultation notes with keyboard. I'm adding an extra text called edited to it. So if I minimize it, right, so you can see a unstaged, here you can see an icon which says that you have a unstaged consultation notes. Like if I move to the other page, any page, like so you can still see that unstaged notes. If I move back anywhere, so you will be seeing that unstaged notes. So if I move to other patient, right, like let me actually go to an inactive patient now. As I mentioned, you're not seeing any floating button here, right, like the consultation notes. It's because the speech assistant is enabled only for active patients. So the taste diabetes is not an active patient, so you don't see it. So when I move back to an active patient, I actually gave a edited text, right? I have added edited here, and it's not, you are not able to see here because I have written it, but I didn't save it. So if you don't save it, it won't reflect in the consultation notes. Now I'll do it again, but this time I'll save this thing. I'm clicking on save. Let's go and see the inner visit dashboard. See, you can see that edited came to the existing consultation. So we are actually every time updating the consultation notes with the current data, and we are seeing it. If you go and see here, it will fetch the latest consultation notes and it will display in the text area. In this application, everywhere we are using OpenMRS endpoints. Reason behind this is any application which uses OpenMRS can integrate speech to text application.
As you have seen in demo, application performance was good. But the application is not running on GPU enabled machine right now. Vakyans API works very good on the GPU enabled machine. Okay. And second thing is Vakyans is supporting multiple uh, Indian languages, as you can see here. So these are the languages, and you can read about these languages on the Vakyans page. So right now we have used just English, that is a plain normal English model. To understand the medical terms, we have to train the models with the relevant vocabulary, and we can use those models for the Vakyans. And right now, we didn't have the NLP library implemented to Vakyans. So if we can implement NLP library to understand meaning out of a sentence, Then we can extend the use cases for other consultation tasks like medication and symptoms and etc. To know about the Vakyans infrastructure, you can go to Vakyan space and the API deployment guide, and they have described few infrastructure requirements here. So for to support 50 to 100 concurrent users, uh, as per them, we need a fully operational Kubernetes cluster with 3 nodes, each containing at least 8 CPUs, 64 GB RAM, and one Tesla T4 GPU of 16 GB. So you can see the all the requirements for Vakyan's infrastructure. Thank you, everyone.